Now, I genuinely love this question because in this question, we're dealing with not just sine rule and, well, we're also dealing with small angle approximations and something else which we're going to have a look at in a bit. So it says that we've been given triangle ABC, where angle A is theta radians and B is 3/4 pi radians, and AB is 1 unit. And using sine rule, we need to show that AC is equal to 1 over cos theta minus sine theta. So from year 12 and from GCSEs, you will remember what sine rule is. I'm going to write down sine rule in this particular question using the lengths at the top. So AC over sine of angle ABC is equal to the other length which is given to me, which is AB, okay, AB, over the angle which is opposite to that is angle C, or angle ACB. Okay, so now I am given everything. I'm given angle B, length AB. However, I need to quickly work out angle ACB. Okay, so this particular angle over here is going to be pi minus, which is 180 degrees. Alright, so pi minus theta plus 3/4 pi. And that, when you expand and when you simplify it, it would simply give you 1/4 pi minus theta. Alright, so that's angle C. So if we now put everything that we know into our sine rule equation, we would end up getting AC as equal to AB, which is 1 unit long, times by sine of angle ABC, which is sine of 3/4 pi, divided by sine of angle ACB, which is sine of 1/4 pi minus theta. So let's work out the numerator here, which is 1 times by sine of 3 pi over 4 is root 2 over 2. And for the denominator, I'm going to use sine of angle A minus B formula, which is the addition formula given to you in the formula booklet. However, I do encourage you guys to remember them as they're very, very helpful. So that'll be sine B cos of A. Okay, so once I've got that there, I can simply say that my numerator will look like sine of pi over 4 cos theta minus sine of theta cos pi over 4. Now, I can further simplify the values of sine pi over 4 and cos pi over 4. I know they are equal to root 2 over 2. So I can just factorize it out. So that will be really simplified in a second. So I'm going to be left with cos theta minus sine theta inside the bracket, and root 2 over 2 will cancel out in the numerator and denominator. So there I have it. I have AC is equal to 1 over cos theta minus sine theta. There you go. So that's part A done. Now for part B, it says, given that theta is a small angle, use the result in part I to show that AC can be approximated to something like 1 plus p theta plus q theta squared. Now, whenever we're using small angle and theta is in radians, we can safely use the small angle approximations, which again are given to you in the formula booklet. So I'm going to just use the small angle approximation for cos theta, which is 1 minus half theta squared, and for sine theta it's just theta, so that will be sorted in terms of small angle approximations. However, I do know that I have to modify this further. How? Well, there is no fraction in my given result. Okay, so there is no fraction, hence I'm going to have to modify it in such a way that I can get rid of the fraction. And the only way I can do that is if I rewrite this expression as to the power of minus 1. Okay, so let's just make sure that that's separate. Okay, so now what does this look like? With something inside the bracket and with a minus 1, how can we further simplify this? Well, we have to use binomial expansion from year 2 or year 13. So I'm just gonna put that in the corner here. So the binomial expansion in year 2 is slightly different when it comes to negative powers, and it's simply, if you have 1 plus x to the power of n, it's given to you as 1 plus nx plus n times n minus 1 over 2 factorial x squared, and so on, where n could be a fractional power or negative. So we're going to use that expansion here. However, one thing we have to do is figure out what our x is. Okay, so for x, I'm going to just rewrite this down as 1 minus half theta squared plus theta. Okay, so this is now my negative, or rather just x. Okay, so I'm expanding 1 minus x to the power of n. Okay, so for that, it's really simple, and I don't need to go very far because it's only asking me to go up to a theta squared term. So if I go ahead and expand it, so I'm gonna get 1 and then minus, okay, 1 as its n, okay, and then x, which is half theta squared plus theta, and so on and so forth. Okay, that's the good news. I don't need to do much. And when I open this up or tidy this up, I will have 1 plus half theta squared plus theta. Okay, so there I have it in the form of what they were asking for. And if I compare the coefficients now, I would notice that coefficient of theta is p, and in here it's 1. So p is 1, and for q, that is going to be equal to a half. So that's basically it. You've got your p and q by using binomial expansion. Now, I hope you found this question helpful, and I am aiming to do more questions like this in the future. Let me know in the comments below if you want to see something more specific, if you want me to do a question of your choice, and if it is hard enough, I will definitely give it a go in a video form. Thanks ever so much for watching.